Hi, I am Yang Chen, and this is my project on illness-related fatigue and information processing speed. Fatigue is one of the most disabling symptoms across illness like ME/CFS, MS, cancer, long COVID, linked to job loss and reduced quality of life. But we don't agree on why it slows people down. Is it generalized slowing? A draft rate problem where brain get the evidence more slowing, or does processing just get noisier? Each points to a different fix. So my question was, how does illness-related fatigue impair processing speed? And what does the relationship between speed, accuracy, and variability reveal about the mechanism underneath? I grounded this in full cognition science framework. Third-grade Crum says cognition is representation plus procedure. Fatigue could break either one. Sawhouse predicts slowing should get worse as tasks get more complex. Radcliffe's draft diffusion model splits reaction time into draft rate, decision threshold, and no decision time, modeling speed and accuracy together instead of separately. And Hawkins frames fatigue as a shift in effort allocation, not just running out of gas, which explains why some patients keep their accuracy but simply slow down. For method, I ran a purposive citation trend search across PubMed, PsychoInfo, Scopus, and Google Scholar. One important pivot, I originally planned to search a fixed list of units, but that wouldn't exclude some strong startings for other units. So I broadened the population side and instead tighter my criteria on the outcome side. Starting had to report the speed plus at least accuracy, RV, or a DDM style parameter. That search returned over 1,000 records between the PubMed and PsychoInfo initially. After title and abstract screening plus Scopus, Google Scholar, and citation chasing, I brought 22 articles to full-text review and retained 17 as primary starting across 6 units population. First finding, slowing is nearly universal. Every population was slower than control. Moderate to large effect in ME/CFS and MS, large effect in fibromyalgia, and in long COVID, patients were about 3 standard deviations slower than norms, scaling with how severe their illness had been. Second, accuracy is usually preserved. Even in chemo patients tested 15 minutes after infusion, that's consistent with people compensating for slower processing by taking more time. But that compensation breaks down at high severity or high task demand. Several severe long COVID patients and cancer patients on that hardest test did show real accuracy drop. Third, variability is not universal signature. MS show it consistently across 4 studies, sometimes a better marker than average speed. Fibromyalgia shows something more specific, not overall noise, but sometimes extremely slow trials, suggesting attentional lapse. Long COVID show no elevated variability at all, which actually argue against a noise account for that group. And here's the finding I think matters most. The 2 draft diffusion starting I found disagree with each other. Post-stroke fatigue shows the efficacy in no decision time. A functional neurological disorder starting show it in the draft rate instead. A third study even located showing upstream in arousal regulation. So fatigue isn't one computational failure. It looks like a family of different ones that happen to share a symptom label. So the takeaway, fatigue-related impairment need to be screened differently depending on which mechanism is dominant. Accuracy only screen will miss a lot of this. My main limitation are methodological heterogeneity across startings, very few DDM starting to compare, and a purposive rather than exhaustive search. So the next step is a single starting using a shared sequential sampling model across matched tasks and multiple units population. Thank you.